Welcome to this video series on key capabilities of the Kalido information engine. In this installment, we will show you how Kalido can leverage data models you have already created to accelerate the migration of information assets into your Agile data warehouse. The model-driven Kalido information engine has the unique ability to leverage data models from various sources, such as the physical data model you see here. Kalido provides an easy-to-use interface to integrate and refactor these models into a single Kalido business information model. Kalido can import models from other tools such as Irwin, Embarcadero Studio, and Power Designer. It is also able to import files that contain a simple metadata description of tables and columns. And Kalido can import these files incrementally, where each successive import adds to the model, enabling you to extend your data warehouse environment rather than rebuild it. Let's import a data model into Kalido. In this example, the model is stored as a text file that describes the objects. Often this information can be extracted directly from the system tables of the database. As you can see, this model is the raw tables and relationships in the system database. BIM has provided some simple formatting, such as the subtypes. And of course, importing a physical model usually means importing the technical jargon used to abbreviate tables, such as PRD for product or CUST for customer. Kalido's name and label management allows you to apply a simple translation file to convert the technical jargon to business terms. With names to work with rather than technical labels, it is now very straightforward to take a data model and refactor it to something much more reflective of how the business sees the world. We have started by grouping the product domain, organizing the objects into a set of hierarchies. Naturally, new objects and associations can be added with a few simple mouse gestures. With a few minutes of refactoring in the Kalido Business Information Modeler, we get a much more business-friendly model. The key thing to note in the Kalido Business Information Model is that it is very easy to understand what reports you can generate. We simply start with a measure and a transaction at the bottom, and then follow the arrows upwards, where we will encounter all the ways in which we can aggregate and filter the measures for a report. Additional imports can be used to extend the model, or new model objects can be created by drawing and linking them into the existing structures. For example, there may be a model for standard geography used in other business models. We can either export and import that schema, or we can simply copy and paste it from the Kalido model. Once the standard geography definition has been imported, it can be attached to the existing model, where relevant and redundant duplication of hard-coded values can be removed. Of course, associations between the geography dimension and the rest of the model will be automatically tracked over time, giving a full historical record of the relocation of customers, suppliers, and shippers. During this process, the warehouse architect realizes that standard geography only provides coverage down to the state and region level, where the warehouse customer requirements utilize geography down to the city and postal code levels. These new levels can be simply added to the model by drawing new boxes for city and postal code, then dropping them into the geography supertype. Finally, we will want to deploy this new information to the Agile data warehouse. The ability to define, redefine, deploy, and redeploy a complete warehouse model with its associated rules is a key advantage of the Kalido information engine. This allows a Kalido project to go through multiple iterations early in the development cycle, before a lot of work has been done to complete the project.